I'm Tim O'Reilly. I'm the founder and CEO of O'Reilly Media. We were one of the earliest companies to highlight the rise of big data. I started talking a lot about the importance of data back 10, 12 years ago in sort of thinking about web companies and what made them succeed. And I used the idea that data was going to be the Intel inside of the next generation of computer applications. That's turned out to be the case. My company now runs a conference on data called Strata, the business of big data. But I'm here with a set of people who, from a range of companies that are involved in this big data space. I'm going to ask them to each to, after I sort of mention them by name, introduce themselves very briefly, what they do, what their company does, and then we'll go into a free-ranging discussion of the transformative power of data. We'd like to, talk among ourselves for a good part of the session, but this is a small room, and so I think it'd be great if you guys have questions that are raised, just become part of the conversation. We'll have a formal Q&A at the end, but if we start saying something you don't understand, feel free to, wave your hands and say, hey, could you expand on that, so on. So anyway, I'd also love, since I do know, I'm not seeing a lot of laptops here in the room, but I know there is a tweet stream. I believe the hashtag is GC2014, and if it,
GC.
Oh, 2014 GC, sorry. It's up there. You guys might want to, in your introduction, identify if you're on Twitter and what your name is. I'm at Tim O'Reilly. And so let's go. On my far left is Michael Woods, who's the senior data scientist from a company called Ayasti. He's going to tell us what they do. And then on my immediate left, Keith Collins, who's the Senior Vice President and CIO at SAS, which is one of the oldest big data and analytics companies and very important company in the space. On my right, Tim Domke, who has the kind of the new age title, Head of Big Data at eBay. And on the far side, Frank Adante, who's the co-founder and chief product architect at the Rubicon project, which uses big data and online advertising, and I believe just went public a couple of weeks ago. So why don't we start with you, Frank, and you maybe just give us a little bit of background on who you are, so it'll give context for your comments, what your company does.
Sure, sounds good. Frank Adante, at Frank Adante on Twitter. So we founded Rubicon Project about 7 years ago with a mission to automate the buying and selling of advertising. So essentially what we're doing is we're doing for advertising what companies like NASDAQ or New York Stock Exchange did for the buying and selling of stocks. So we provide a solution to sellers and buyers of advertising, the largest websites and applications in the world. So companies like Wall Street Journal, as an example, who are selling advertising, to some of the largest agencies in the world, like Omnicom, as an example. And our platform automates the buying and selling of those transactions. From a big data perspective, our platform reaches 97% of the US internet audience. So you probably interact with our technology every single day, though you may not realize it as you're going through these websites and applications with that infrastructure that powers that advertising. And we're processing now about 3 trillion transactions now on a monthly basis. So that's just petabytes and petabytes of data.
One of the things that I would mention here, I understand that Mike Milken opened this conference talking about disruption, and you guys are a great example of disruption. The business of placing advertising used to be, you got an ad sales rep meeting with a company, kind of like the Mad Men days, kind of persisted until all of a sudden we effectively have programmatic advertising automated, with very precise targeting, via big data, and you guys are in the middle of that. And I think that disruption is really just starting to hit the advertising industry in a really deep way, where it's becoming a bigger and bigger part of the spend. So we should return to that subject of disruption. All right, Tim?
I'm Tim Domke, head of big data at eBay Inc.
Twitter handle?
No.
Oh, okay. All right.
So eBay, you're very familiar, no doubt, with eBay, our marketplaces business, connecting buyers and sellers. The eBay enterprise, though, is much broader than that. We own PayPal, leading payments business online. We own a company called eBay. We've rebranded it to eBay Enterprise, which is an e-commerce platform for some very large online retailers, so Toys R Us, Ralph Lauren, Levi's. And so the broad view that we have on commerce means that there's an awful lot of data that comes through our hands. We enabled $212 billion of e-commerce last year, which is about $1 in $5 in e-commerce. And for every one of those dollars, we've got a story to tell about it. We know something about what was bought, who bought it, how they bought it, what time of day, was it a mobile device? And that gives us an enormous opportunity. We use that internally for a lot of obvious things like risk management in our business. One of the more exciting spaces that we're in now is starting to externalize that data for the benefit of our partners. And this includes things like baselining your business. Is your business growing? How's it growing compared to the industry that you're in? Some of it is individualized experiences. When consumers come to your site, are you able to connect with them immediately on their terms? What products are they interested in? And big data has given us some great opportunities, finding correlations that are counterintuitive or anti-intuitive in some cases, that the brand of jeans that you are most likely to buy might be more predicted by your purchases in auto parts, for example. And those correlations are enormously valuable for us and for our partners.
Cool.
Keith Collins, at Keith Collins. Showed up at SAS on a 5-year plan about 30 years ago. It's been a fun run. Very interesting company. So when you talk about the analytics space, yes, we clock in at about 35% of the market share for analytics. The next 5 below us don't even add up to 35%. So it's a very fractured market. What do we do? If you use your credit card today, most likely it's going through SAS to determine whether or not you should get that credit or it should be denied for fraud purposes. If you take any drugs today, the drugs that you take were probably validated through the analytics using SAS. If you were looking at the CDC for a health outbreak, you'd be talking to them about how they use SAS to understand the population. So it's broad range, which is one of the great things about analytics and this explosion in the digitization of the business. And this is part of what Mike Milken was talking about, is this change that's occurring. It is very different. One thing I'd put out there is I hope we talk some about the real shift here is about big compute. Mm-hmm. We can talk about big data, and yes, the sensors and the Internet of Things are real. What's changed is the computational speed at which we can come to these answers.
That's right. And also the availability of that computation to smaller and smaller companies.
Yes.
You know, through cloud. So, it used to be that this was the province of a few companies, and now it really is available to everyone.
Well, it is, and the thing that I'm finding so interesting is people will talk about a lot of conversations here and about disrupting your business. So in my tenure at SAS, we've disrupted ourselves. We're in our 4th disruption right now of remaking our whole infrastructure and our framework and what we're delivering to our customers, changing to use large-scale compute clusters, doing it all in memory. And these are hugely important, not because they're just faster, but because they change the way people do business.
Yep.
So that's a very interesting time. It's going to be an exciting conversation.
Yeah, when you can do the analysis in close to real time, it becomes a very different exercise than when you do it slowly.
Yes.
Yeah. So, Michael?
My name
Yeah.
is Michael Woods. I'm actually
Yeah.
part of that fractured base that's below the 35% that SAS has. So I'm part of a company called IASD. IASD was founded to commercialize machinery developed in a theoretical mathematical setting at Stanford University. And where we've found these techniques derived in the field of algebraic topology, don't worry, I won't tell you much more about that. Where we're doing is what we have is a fundamentally geometric framework for the interpretation of information. And it really what we're doing lends itself precisely to the themes which were just identified. With the increasing availability of computational resources, you can do more complicated algorithmic mathematical things that enable you to better and more rapidly interpret the outputs, the algorithms you already have. What we have is a framework, isn't a particular algorithm. And in this framework, we found a broad array of applications that can identify persistent structure in complex data. Right now, IASD is working with 7 of the 10 largest pharmaceutical companies to accelerate the discovery and testing of compounds. I myself lead our financial services practice. I actually came from BGI, which was acquired by BlackRock. So I have my area of focus is really understanding how you can apply these novel frameworks for the interpretation of information to make better decisions. Whether it's in regions about customer intelligence, whether it's identifying complicated market states where certain trading models work well or work more poorly. These are the things that I work personally on, and our company as a whole. Actually, another major initiative I should mention up front is that we're working in terms of this emerging space of data-driven personalized medicine. We're working with a major hospital system to deliver systematized care paths. So in the context of a particular diagnostic outcome, in the context of a particular patient history, how do you deliver the optimal sequence of care given the data that you have?
Yeah. So I wanted to start the conversation by making data real to people, and in particular, explore a few of the non-obvious ways, perhaps from your customers or your interactions, that data has transformed a business process. And some of these things are out there on the frontiers of science fiction. But let me just start with a couple. You may remember that you may have heard that Monsanto recently bought a company called Climate Corp. Climate Corp was actually started by a former Googler who realized there was a lot of really additional intelligence to be derived from weather data, produced by the government, but really used in kind of old-fashioned ways. And he said, well, we can get a lot more out of this. And we can also gather new sources of data to provide much more valuable, more precise weather data. So Monsanto came to realize this, bought them for roughly $1 billion. But what's really interesting is that in the new group that they put together at Monsanto, the other company is a robotics company called Precision Planting, which uses that very, very precise data, including satellite data, data from drones, to actually do micro-targeting of fertilizer or water, and so on. And you also literally to do the planting without a human driver. So you've heard about the Google self-driving car. Well, Monsanto is supplying equipment that allows for self-driving tractors. And you look at that range from weather data to seed planting, owned by Monsanto, and you go, whoa, that's a whole different take on data is becoming transformative, and through precision planting, effectively Monsanto is competing with John Deere. They're actually supplying new guts for tractors that will make them be smarter. Google getting into the auto market again. They've gathered all kinds of unique data. One of the big hidden connections that people don't realize when if they've heard about the Google self-driving car, that it's actually partly driven by Google Street View. That they kind of drove all the roads, and yes, they produced these nice images that you can look at on Google Earth or in Google Maps for turn-by-turn directions. But more importantly, they mapped all the roads in the U.S. much more precisely with sensors. They measured the width of the lanes, the distance to the stoplights. Google's chief scientist said to me, he said, it's kind of a hard AI problem to pick a traffic light out of a moving video, but it's actually a very simple AI problem to figure out if it's red or green if you already know that it's there. And so again, you see data coming into the physical world and not just this sort of ethereal area. So that's sort of my contribution to that discussion. Any of you guys want to throw in some surprising perspective on how data is transformative from one of your customers or in your business?
I'll jump in. I think that's an interesting perspective on agriculture being in a space now where the cutting edge is new data collection and feeding more data into their algorithms and their methodologies to derive intelligence. In a lot of industries, in many industries like obviously commerce and finance and several others, there is a ubiquity of data already, that the data is almost free. The price of storing data has gone down, the price of collecting data has gone down. And so you have a number of industries where the challenge is not how do I get some interesting data to go do something with. Instead it is, we're up to our noses in data, and then now what do we do with it? And when you're in that space, the opportunity is, it turns research a little upside down. Historically, you would say, okay, I'm going to start with my hypothesis. I'm going to do some expensive things to collect specific data in a structured way to speak to that theory I have, and then we'll see what the results are, and maybe you iterate. This is a different model. This is one where the data is already there, and now you're bringing hypothesis to it. And you're saying, well, what does the data tell us? What correlations can we find? And in our space, in the commerce space, a lot of it is these counterintuitive correlations, where a lot of marketing historically has sort of started with psychology, like, well, you live in Green Bay, so you're probably a Packers fan. And then data is used to sort of tune that. We're able to do things. We've got a clothing company that we work with, and they're expanding their product line into women's swimwear and activewear. And so we're able to look at data and say, well, what are those particular customers that you're interested in? What are the other buying patterns that correlate with that particular purchase that you're trying to drive? And the correlations that we find, given the data set that's as broad across commerce as we have, is that purchase decision is mostly driven by correlations in cell phone accessories and home decor purchases. And that's not something that this clothing manufacturer would ever theorize. They would never say, oh, we're going to sell swimwear, so eBay, can you help us figure out who's buying cell phone accessories? That question would never come in that old model.
We should come back to this, because there is a question of what's the role of sort of intuition and research in how to think about what to look for versus more generalized models of having the data itself talk to you. But let's come back to that in a little bit. Anybody else have a sort of an illustrative story?
There are a couple of things that are
impact on
happening
data
that are interesting right now. So the financial services sector has been sort of top of the game at understanding using demographic information and how to leverage that. We're about to shift into a period where we're going to talk about high-value entities and knowing them individually. So one of the problems they had when they went to Desert Storm was the maintenance plans around Blackhawks were all about just standard maintenance schedules. But once you put them in a sandy environment, all hell broke loose. Right? Now as the sensors become available and you've got the data, now you have an opportunity to treat every important device, whether that's your refrigerator or whether that's a helicopter, to know exactly what its usage pattern is, what the frequency, when it's likely to break, and now to reach out, and there's just tremendous number of opportunities.
Instead of using mean time between failure, you literally have an engine saying, hey, I need service.
And then you can look a slightly different direction of the opportunity. Well, how do I leverage data that I might not otherwise use? So if you're a healthcare insurer, your natural view would be to, well, I need all this healthcare data about my patients and my clients. But HIPAA regulations make that really difficult. I have all this privacy. It turns out that a few of the healthcare insurers say, well, I can get their purchase data. And if I understand what the client is purchasing, beer, cigarettes, what frequency, I can predict their health.
Yeah.
So this idea that the data availability and where you look for data and the hypothesis you establish, extremely important.
Yeah, it's interesting. I talked to Jeremy Howard, who was the chief scientist at a company called Kaggle, which runs these data competitions, about the characteristics of the winners. And I said, what do they know that other people don't know? He says, oh, they're all using the same algorithms. If I were trying to reverse engineer, I'd say, find the people who are the most creative at figuring out what data to throw at the algorithm. And so that's a little bit similar to what you're saying there.
Yeah, some work that we've done with Generax directly with what you're describing is, in order to get that engine to raise the flag to say, I need you to do some preventative repairs today, you need to be able to detect the signature of the previous usage, which is going to identify likelihood to fail. Some of the work that we've done in heavy machinery is found that these patterns can be very, very complicated and very sophisticated. So in the context of a lot of what we've discussed, I think it's actually important to differentiate between big data and complex data, because oftentimes what we find is that big data is boring. If you're hitting the same sensor and there's no variation in that sensor, it doesn't matter that you've collected a petabyte of data, there's not meaningful information in that data. In the context of this particular heavy machinery work that I'm describing, these were machines that were throwing off terabytes of data every sort of instance they were used. But it was really the ability to use computational power to identify the right sensor and the right signature in the data associated with that sensor that was indicative of future failure. And that, to me, is an important point when you think about these data problems, that it isn't just a size, it's a complexity issue. And you also, speaking to the sort of algorithmic sophistication, one of the things that we've found is that your ability to use algorithms effectively is often constrained by sort of your natural domain. So one of our strengths is that we bring together life sciences, financial services, fraud. We're able to actually identify spaces in which the right algorithm may come from a domain that's totally non-obvious. Some of the work I did with a major capital markets business, we applied an algorithm that was generally utilized in gene sequencing to effectively identify market states that were interesting to the client. So it's interesting to hear, because SaaS is certainly positioned in a space where they get to see these cross-domain functionality applications.
Yeah, your point about finding unexpected uses reminds me of a conversation I had with Sean Gorley over at Quid, which is a big data company, and they've ingested patent databases, scientific literature, and then they look for hidden adjacencies. Hey, there's actually some work over in this field which is actually very, very close to work in this other field that there's no crosstalk between them because they don't think of them as the same field, but they're using the same technology. Great example of this is one from my own past. We did some of the early work on collaborative filtering. Used to own some patents on that. And, it was very related to the same algorithms were used in circuit design. You never would think, oh, collaborative filtering, circuit design, those go together. But there are a lot of ways that there's hidden value in those adjacencies. Yeah.
If I could just add on, we've talked a little bit about some of the purchasing habits and data that companies are able to process on consumers. If you look at the advertising market, it's a $200 billion market where you've got hundreds of thousands of advertisers that are trying to reach consumers. And on the other end, you have these consumers that say, I hate advertising. Right? So the relationship between the advertisers and the consumers is broken. And part of that's because we haven't been able to connect them in the past. There's been this series of Excel spreadsheets, this manual effort, this work that had to go into being able to reach those consumers, and that chain or that linkage of data hasn't existed. So one of the things that we've done at Rubicon Project at a very basic level is we've now connected over 100,000 advertisers with over 600 million consumers around the world. And we've done that across the entire internet, not just one website. And the reason that's important is that unlike other markets where goods might be non-perishable, like take a share of stock as an example. A share of stock can sit on the market for days, weeks, months, et cetera, right? In advertising, you have 80 milliseconds to be able to connect an advertiser with a consumer. It's like an empty airplane seat. Once that ad experience is gone, you can't go and recapture it. So you've got 80 milliseconds to use tons and tons of data from both the buyer as well as the advertiser who's trying to reach that consumer to understand that consumer's preference, make all these calculations, conduct an auction, if you will, and then connect that consumer with that advertiser brand. So it's a massive technological challenge to be able to do that quickly. And it's only until recently that we've had the computing power, as you mentioned, at the low costs to be able to store that data, process that data at a scale that is now cost efficient to be able to do that. But now that I think that infrastructure has kind of been laid out, now I think we're going to see all sorts of new usage of data, and I think we can start to repair that broken relationship between the $200 billion that's spent by advertisers and these millions and millions of consumers.
So you bring up kind of the whole aspect of real-time data. Keith, you had some skepticism about real-time data when we were talking in the prep call. Do you want to talk to that a little bit?
So maybe not skepticism, but I think it's an opportunity to talk about educating everybody to help them understand. There's this real need to have this historical understanding. If you're going to do predictive asset management and you want to understand failure on a device, you have to have this historical baseline to build your models and drive that. And there's a lot of talk right now about machine learning and how fast you can do that. But there's also this huge opportunity, which is the automation of that insight into your processes. And a lot of people sometimes when they say analytics and real-time analytics, what they're really talking about is operationalizing the analytics and the decisioning. And that's important for people to understand the difference in those two, right? The value of having historical baseline, especially in a regulated industry, especially where you need to be able to say, I understand the efficacy of the drug, I understand the impact of the decisions I'm making in the marketing campaign around diversity. These are things that you need to be able to baseline, yet turning that into an operational in real time, making that decision in 80 milliseconds is critical to where we're headed in terms of leveraging the value of analytics.
Yeah, okay, that's fine. Yeah, that makes a lot of sense. By the way, I kind of want to talk a little bit about this notion that data must be either big or complex to be transformative. You know, a really great example, how many of you here in the audience know about Uber? Okay, just about all of you. When you think about that right now, that's basically a business that's made possible by data. You know, because we all have GPS-enabled cell phones, you're able to know where the passenger is, and you're able to know where the driver is. And all it took was somebody saying, wow, we can connect those dots, and that can give us a totally new way of thinking about a very old business. And I think that there are a lot of disruptions that are going to come at us simply because somebody realized, oh wait, we know something now that we did not know, you know, when this business existed before, or we have a capability to know. So I think that there are going to be a lot of just slap your forehead moments when somebody says, oh my gosh, why didn't we do that before? You know, it's not all rocket science. I mean, you know, that's actually all infrastructure that Uber didn't have to build. They just had to connect the dots. You know, even the services like, well, you can call the driver or text them without giving them your phone number. That's a back-end service that exists in the cloud already, you know, and it's just putting the pieces together in a new way.
Yeah, that makes a lot of sense. I think there's the one place where the sort of things that we're working on can be highly complementary to that worldview is that it can often be hard to figure out which is the simple piece of data that I should be paying a lot of attention to. So in the context of Uber, it's self-evident. It's where are your cars, where are your passengers, and being able to connect those pieces of information efficiently is a straightforward task. If you're dealing with data that has thousands of dimensions, it's very much non-obvious which of those data points you need to pay attention to, even if once you know the right data point, it does become a very simple and straightforward data problem. So I think there's a lot of head-slapping moments ready to be had in complicated data settings as well. So it's not not just connecting the simple, but actually connecting the simple component of the complex.
Yeah. I actually think about that eBay is a very early example of that. You guys went, wait a minute, you know, this huge distributed garage sale made possible, you know, once we actually put this stuff on the internet as data. You know, you don't actually have to go, you know, I bought an anvil from somebody in Indiana for my son-in-law, you know, so like it shows up on the doorstep. You know, it's kind of crazy.
Well, I think you make an important point about you know, big data and volume and complexity. Big data, it's almost a regrettable term, you know, because it draws the attention to the volume. That it leads people to believe on initial inspection that this is about lots and lots and lots of data, and really, I think what's interesting and important about it is that it's about identifying or emerging out of that patterns that are human conceivable. That when you look at so many data points, you can take the Uber example or a number of examples from the eBay business, the data is you hit numbers that you can't really think about within a human brain.
Yeah.
You can't understand them, and whether they're very large or very small, whether it's about lots and lots of people and lots of purchases over a broad economy, or if it's about clicks and hovers over UI elements and so forth, you get to numbers that are just beyond human comprehension. And so the interesting thing about data science is the ability to approach that large data set and emerge from that something that is conceivable. And whether it's an aha moment like, oh, duh, of course, now this makes a lot of sense, or it's counterintuitive, where you say, I can't make the psychological connection between this purchase pattern and this purchase pattern, but the data is strongly correlated. Whether it's intuitive or not, the power really is that those patterns inform us.
Yeah, I think that's totally true. Let me just bring up one other topic, which is the topic of precision. We've used this term precision medicine. There's also the term healthcare hotspotting. This notion, for example, this physician in New Jersey, Jeff Brenner, did a bunch of analysis and realized that a huge proportion of the emergency room visits were driven by a very, very small number of patients. And the analysis was, well, actually, if we intervene for that small number of patients, it will actually have a disproportionate impact on the cost of the system. Similarly, in precision medicine, it used to be you'd say, well, this drug works on, 70% of the patients, and you'd say, no, actually, it works. It works for 100% of the patients who have this particular gene, which is a very, very different statement. Even though, because one is we just don't know why it only works 70% of the time. The other is, well, we actually know which people it will work for, which ones it won't work for. Right? Obviously, you've done a bunch of work in that precision medicine area. Maybe you could talk a little bit to that, Mike.
Yeah, absolutely. So biological systems, given their endogenous complexity, are really ripe for disruption with powerful computational architecture. What this means is that we have a very hard time going in, looking at the genome and being able to say, this is the part that matters for this type of person. And so what we need, and what this emergence of I too sort of hesitate to use the word big data. I think it's more extant data. I mean, before we didn't have the data, people weren't storing it, people couldn't process it. But what's happened is these new computational tools, the decreased cost of computation in general, enables you to actually parse the data sets that were previously imparsable, such that you can identify which gene matters, you can identify which compound might be most efficacious. To reference some of the work we're doing right now, so compounds are extraordinarily complex. The ability to computationally spawn new compounds and simulate the performance of those compounds relative to certain receptors that pharmaceutical companies care the most about is an extraordinary area for innovation right now. And this is a space where we see a lot of opportunity in terms of making more efficient the sort of drug development cycle, the investment in, we've talked about precision medicine in terms of identifying the characteristics of the patient that are going to make them most treatable by a particular sort of sequence. There's also a direction where we can say, what are the set of compounds we can most effectively identify that are going to treat the most general set of patients? So you can really think of the problem as being attacked on both sides.
Yeah, there's another aspect of precision. I was talking recently with someone who's doing research at MD Anderson Cancer Center in Houston, and they're basically using nanoparticles coated with various kinds of receptors to basically micro-target cancerous cells, so they can actually image incredibly precisely tiny tumors. As opposed to, well, we have to be able to see it to be able to deal with it. All of a sudden, you can kind of just you can kind of send in your scouts and paint the cells. So they show up in bright lights and at a really much more targeted level.
That one's fun. There's a project at North Carolina State called ASSIST, where they're studying the use of nanos, and they're powered by the body. And so one of the questions is, what's the effect, and how do you actually understand as parasites in your body how to regulate them, and the information outflow of these devices is amazing.
So quick take, what do you think of the industries that are most ripe for disruption?
all. I think this was, to me, the most exciting thing is and several people have said it isn't always about big data. There's just this opportunity to bring together data like we've never done before is amazing. Just simple examples of largest pork producer in Germany pulling together what their inflow of hogs are going to be, so knowing them in detail, with defining those cuts against the market need, doing the workforce allocation every day.
Yeah.
Right, and optimizing the workforce. Huge change in the value of the business.
Yeah.
Data they've had,
Yeah.
but now a way to bring it all together.
Yeah.
Same thing happening across warranty analysis, being able to do text mining across all of the tech documents as well as incoming customer feedback. This happened actually went back to the TREAD Act. We could show that if they had done text analysis and included in that warranty analysis, they would have seen the problem showing up for the tires, the Firestone tires.
Yeah, yeah. Yeah, there's so many great examples. One that I was just hearing about the other day, I'm associated with a nonprofit called Code for America, which tries to bring technology into government. And one of the problems they're working on is jail overcrowding. And it turns out that, as in so many other cases, a little bit of data goes a long way. It turns out a lot of people are in jail because they failed to show up for a court hearing. And that imposes costs on the system. You've got overcrowding, you have to process people. And you can actually intervene in a simple way, simply sending them a text message reminding them to show up because instead they got some letter that they didn't get delivered to them because they don't have an address or whatever. So there's a lot of interesting ways that you can do data interventions to solve a problem that you might not have even thought about as a data problem. All right, well, I'm wondering, do any of you here in the audience want to start getting in on this conversation? I think we have a wireless mic, but so I think that since they're recording it, let's wait for the mic to come around over here first, and then, oh wait, no, up here in the front. We'll get to you, but he started the ball rolling.
Hi everyone, thank you for coming in today. Just a quick question. Historically, when I think about corporate espionage, I think about companies trying to find out about different initiatives one company may be doing, a competitor may be doing. I think about IP. And now when I think about big data and the fact that it really starts out on a transactional level, these are like little decisions or, one purchase on eBay can create 500 data points. That individual transaction might be extremely valuable to a competitor like Amazon. What are you seeing in terms of protecting that data? Are you seeing companies going after other companies' big data? Since it's basically free to keep in mind this data, is it moving freely? Is it very easy for someone to take that data from one company to another? Just your thoughts there.
Maybe I can address that. So in the advertising world, you've got all these different websites and applications that have a sliver of a consumer's overall internet experience, right? So if you go to CNN as an example, CNN can infer that you're interested in news. They might know the type of news that you're interested in, but they have no idea what your interests are or your experiences are across the entire internet. So this poses an interesting question, right? And that's that. Does CNN want to have data to better understand that user so they can deliver a better user experience or better advertising to that particular user on that particular website? So this is an area that we've been challenged with in thinking, right? It's because a group or a network of different companies could benefit from each other's data, but they have to have the choice or the control over how that data is used. So if you think about data as a chain, I think we use data as kind of like this proper noun, and we look at this as just this one big ball. But if you look at it as a chain instead, and if what we've done is we've said, hey, websites, applications, what pieces of the data are yours? Let's call it first-party data. That data is theirs. Nobody else gets to have it. It's their specialized data. And then there's another part of the chain that's in aggregate. And our customers allow us to use this data in aggregate, anonymous, non-PII, type of information, provided that it's not that first-party data, to better understand those consumers, because if they could better understand those consumers, then it benefits not only their own website or application, but it also helps the advertisers to grow the market, because they're now better able to reach consumers in a way that they weren't able to before. So I think the short answer is there's data that's clearly owned, and that needs to be protected, and platforms need to protect that in the transaction. And then I think you need to give companies and consumers, ultimately, we haven't even talked about the consumer part of this, control over who gets to use that data in which ways and how do they benefit from it.
Yeah, I think that's really well put. As you described, the first-party data, it's not a new security concern that is proprietary to a company, and it would be concerning if that data were ever to be leave the bounds of the company. So there are individual transactions and personal preferences and customer data and so forth. The security around that has always been very important. I think that you raised an interesting point, I would say, in that as big data can leverage that in new ways very positively, what perhaps are some threats around leveraging that in some negative ways. But I think that's still a little theoretical because it assumes that a large infiltration of data or a large compromise of data as a starting point. And so I don't think that data science enhances the need or amplifies the need for security. I think the need for security has pre-existed, and it's still very important.
I think there's certainly a need for us to rethink our basic security models. One of the things that we haven't really addressed your espionage issue yet, but let's talk a little bit about privacy before we come back to that. The NSA controversy really highlighted the fact that when we think about privacy, we do think about primary data. Oh, we're worried about, are they listening to our phone calls? And it turns out, well, maybe they don't actually need to listen to our phone calls even, because there's so much information you get simply by knowing who's talking to whom, when, where, how, and that whole subject of metadata. And so then we say, oh, well, we have to shut that down. That's been a lot of the response in the European Union. We can't keep that data. We can't. But then it turns out, well, you can't deliver certain kinds of services. And so all of a sudden, we're really in this debate. If consumers are willing to give up this data in exchange for a service, is it private anymore? And I think we need really a broad conversation about what the rules are of privacy. And the old model from things like HIPAA, where well, here's some personally identifiable information. You cannot reveal it under any circumstances. And yet people are quite willing to reveal it for a very small exchange of value in the form of a service. So we're really in a shift about what needs to be protected and how. And I really liked, there was a quote from Gibu Thomas, who's over at Walmart, he said, don't be creepy. He said, your customers know when you're using their data on their behalf rather than against them. And that's certainly one piece of it. But again, there are bad actors out there, and whether it's for espionage or simply, people who are trying to, steal, say, credit card data, and you must deal with that a lot at places like PayPal. Daily battle.
I'd like to address maybe two things there. First, and it's sort of played out here in several of different sessions, people talked about whether it's the autonomous vehicle, having vehicle-to-vehicle communications or vehicle infrastructure, that as consumers, we make a value-based decision to share information as long as we get a good. And I think that's going to play out in spades. I think simply the consumer is going to drive most of that sharing and how much they decide to share. And I think we will have some of these first-party opportunities. The thing I'm most concerned about is whether or not we understand the value and the social good of data. Mm-hmm. It's taken us nearly a decade working with the pharmaceuticals to get them to begin talking about trusting and sharing their clinical trial data so they can look across the different drug sets and interactions. That takes a tremendous amount of understanding of the social value of data and people
The
like
social value of
Just-
sharing.
Yes.
Yeah.
And that's going to be tremendous, but it only happens though if we have people like the people in this room understanding that how important that will be to the good of society, whether that's water distribution, whether that's understanding our DNA encodings and the impact of the environment. So that's a place where I encourage everybody to try to balance and understand consumer demand will handle most of the privacy concerns about the individual. How are we really to come to the fore around the social good and the social value? If I come back to just the espionage piece quickly, it's really interesting. The shift right now is to move away from signature detection. We know everybody's getting in, and the question is, can we determine what's leaking now? And so one of the big data problems that's going on is, can we take think about every device that's connected in your network, all your employees, everything they connect, and looking at that on a 5-second basis of what's happening, and then detecting what the anomaly pattern is over time. That's really one of the great opportunities with big data, is looking at and trying to find this hidden pattern that's happening over time, small leakage that just begins to show up. Exxon is really struggling with this. They see China phishing through their employees' home computers and then sending phishing emails internally, and that's how they get in. So they know they're in. So the question right now in cybersecurity is, how do we find out what's going out?
Yeah, I have to say it's very hard to harden everything. I think one of the big security issues is actually, how do you design systems that fail gracefully rather than assuming that you can somehow protect them and make them super hard. There's this really interesting small conference called Suits and Spooks, and there was a guy who spoke at it last year, and it was a session on actually securing they're now calling the industrial internet, sort of power grid and so on. And this guy was a former Mossad agent who his talk was of the form, well, I was trying to think, how would I take over a part of the power grid? And so I thought, well, I'm pretty good at surveillance, so I'll go, I'll go, watch at this particular substation, see if I can pick up some data. And he sort of camped out there, and he found some guy who was outside with his laptop, and with a pair of binoculars, he got his password, and then he said, and I thought, well, what would I do? He's probably going to take that laptop and he'll leave it in his car, and so I could easily break into his car. So I did. I got the password. He kind of went through the thing, and the whole talk was of the form, well, I would do this. So I did. He eventually took over the substation, and, just by kind of just this series of well, that's how I would go about it. So I did. And it was a fascinating talk. Anyway, we should go on to another question here. Over here, Thomas.
Thank you. Talking about big data as a service, is there a sense that self-serve big data as a service is realistic? And the sense of my question is big data as a service a consulting business, or is it a consumer business in a sense? Do you need to be a car driver, which most of us can be, in order to use big data to solve your problems as a business? Or do you need a jetliner pilot to sort of pilot you through what the data can mean for you?
I'm not sure I completely understand the question.
I'll take a stab at that. There's a couple different things. One is data as a service. There are going to be markets for data. A lot of the public data we're going to simply show up. So just this week, I think LA published 160 data sets that are now publicly available for anybody to start doing analysis on. So in terms of will data be available, big, small, otherwise, there are going to be markets for both public data and private data. The other question of can you drive yourself really depends on the objective. So if you're saying, can I do the analytics myself without having to know what hypothesis or what tools? No, we have to have a level of education to do the analysis correctly. We were talking earlier, the big shift is so much of the analytics are going to be embedded in your process. It won't be about going and getting data. It's going to be that the markets, we will have solved much of that. Just to go back a while ago, everybody was asking this question, can I just have a black box tool for doing the analytics? Do I have to have people in white lab coats? And the answer is you still have to have educated people to ask the right questions. The difference in what we're delivering to our customers and solutions is we've baked the analytics in directly into the business process. So that's really, I think, what changes here is so much of what we do have analytics built into it, you just don't know.
Yeah, I think there's a really great line from John Madison, who's the Chief Medical Information Officer at Kaiser. He said that we have a conference on data in healthcare, and he said that the big question of the 21st century is going to be, whose black box do you trust? And because the fact is there are going to be so many areas where the data and the analytics are sort of baked in effectively into some kind of autopilot, and it's going to be a matter of somebody has engineered that. But to your point, there's a huge shift in the way you use data in a company from the idea of the sort of the analyst providing input to management, or a quarterly report, or a monthly report, or a daily report, and into you're actually building a system, and the analyst is providing input into the design of that automated system and the updating of that automated system.
I love the quote about whose black box will you trust, and that is, I believe in that future. I believe that we're headed to a place where enterprises of all sorts own their own data processing, own their own data science, own their own big data capabilities, and then without sharing the raw data, the source data, the transactional data, the proprietary data, without sharing that, are able to share in a market of insights. This is what I know, this is the conclusions that I've come to, that I'm uniquely positioned to come to those conclusions, and I believe they're of value to you. And I believe that that's where we're headed.
Yeah.
I don't think that we're there now. And then I'd say maybe to answer your question very directly, the data scientist is still a very important role in the generation of technology that we're in. And that role is one that, it's a scientist, but there's an awful lot of art in there as well. And so, or business acumen and an appreciation of the strategies that you're pursuing, so that the formation of the questions in that pool of data makes sense for your business. And that's something where I really truly believe that we're in a phase of almost re-education within the enterprise, that we have a generation of technologists, we have a generation of data analysts and business analysts who have spent their careers in constraint. I can only get the answers out of the data that I preconceived when I built those data structures. And what's very exciting about the big data movement is that the tools and the data processing and the data availability has come to a place where you can get answers from that data that were not preconceived. And so there's an unlearning within the enterprise of those constraints. And the data scientist, I think, is a leadership role in that revolution.
Yeah, and that's going to get even more true as we get into the Internet of Things, with more and more sensors driving data. It's going to lead to even more approaches. There's a great line, was actually originally said about crowdsourcing, and I forget who said it, but was it's a lot easier to find a needle in a haystack if the haystack helps you look. And it's going to be so true. You think about embedded sensors everywhere, reporting data that you didn't know you needed until it showed up. And I think it's going to lead to some real changes in how we think about all this. More questions from the audience? Do you pick? Over here, there was somebody over here, yeah. Oh, no, this guy here, yeah.
So, Tim, you've been very careful a few times to refer to correlations and finding correlations, which suggests that there are certain kinds of questions that are very well suited to being answered by what we refer to as big data. And there probably are other kinds of questions that aren't very well suited.
That's right.
And so I'm wondering, a question for everyone or anyone, how would you articulate, where would you draw the line between the type of question that is well suited to being answered by big data and the type of question that isn't well suited, and why?
It's a fascinating question. I mean, the word correlation I really don't like because it posits a particular analytic structure. And so there's two ways to answer that question. There are the questions who have been answerable using existing techniques and computational approaches. As those approaches get better, we're finding we can address more questions. So it's not in any way a static bogey. There is another nature of implicit in your question is, are there systems which are just not well modelable? I mean, the implicit hypothesis about data science is that your data is representative, and given sufficient data, you can identify the persistent structure that you care about to answer your question. There are settings in which you don't have enough information. There are settings which might be too dynamic, where the observations are not consistent through time, such that those things would not be well answered by analytical tools. But I think the idea that there's a static way to answer that question right now it's a bit too strong. That what we're specifically working on is broadening the class of recoverable relationships. That historically correlations are it's a linear relationship in a pair of variables. We know that is explicitly not the dominant form of relationship in real world data. That is a particular form that happens to work given the analytical tools we've had.
And you mentioned it somewhat earlier. It really depends on, are you trying to find what is the normal?
Yeah.
Or are you trying to find what's the exception? And that really drives a lot of what your approach is.
That's a great point. So one of the things that we've had great success at doing is characterizing what's fundamentally anomalous. Now that unto itself is a very valuable piece of information. It may not answer the exact question you asked of your data, which is to say, how do I treat this patient? What's the next compound I should deploy? Which trading model should I use? But that piece of information, knowing that you're in an extraordinary state, enables an individual to then make a better decision around how to manage that system. So there are questions which might not be fully answered by the data, but that we can begin to answer in ways that are better than we've really been able to answer before.
Yeah, I think my quick off-the-cuff answer to that question is there are going to be a lot of questions that we think are on one side of the line until they aren't. And if you look at, there was a time back when they first started trying to forecast weather where that seemed like a pretty impossible problem, and they made a lot of progress. And that's kind of where we are with earthquakes. Are earthquakes fundamentally unpredictable, random, or will there be a point when we actually have enough data that we will be able to predict them? I don't really know. I think that one's probably further off, but there are certainly cases where there was a problem that used to be really hard, and you go, no, actually we made real progress. So, I think we'll expect to be surprised as that line, waves around. Down front.
I had a similar question, follow-up. So there's been some examples of where parsing big data yields correlations, but not causality. So are there any risks or constraints to sort of using the observed correlations, but not understanding the causality?
Yeah, that's a
yes.
Yeah.
So I mean, if you take a trading model and you put a bunch of money behind it around some spurious correlation, you lose a bunch of money. I mean, you treat people with the wrong compound, they die. I mean, so the idea that there's not a generalizable form of stability. So this is really where, depending on the domain, you need to have a robust validation procedure to make sure that any insight, any structure that you detect, any prescriptive model is validated. And that is something which can be either extraordinarily difficult or it could even be trivial. But that's something we work a lot with our clients to say, before we work on any project, any answer that we identify for you, we need you to be able to test it. Because it might be a great answer or it might be spurious, but without having a well-calibrated validation procedure, the answer is essentially worthless.
There's also, I think, a set of things that are neither true nor false. What Milton said, there's nothing either good or bad, but thinking makes it so. George Soros calls this reflexive knowledge, things that are true to the extent that people believe them. Markets are a lot like that. History is a lot like that. So you have this sort of interesting dynamic. Sometimes where it's neither is it correlation or causation. There's a third category, which is we don't know which it was, but it actually changes the behavior of the system regardless. And that's sort of a really interesting area to think about and exploit as well.
I think a lot of data sets are good at describing what, and in some cases when, but very rarely why. And so when you're approaching a data set that doesn't include rationale or reason within it, you can infer and you can approximate some causality based on time sequence and precursor events, but where the risk is significant with being wrong, you absolutely have to have an external validation model.
Yeah, so we can do one more question.
Hi.
Okay, over there.
Hi. Thank you. I believe that the data that I produce as a human being is my own asset. And do you think that we are reaching the day that you will pay me for that asset? I mean, it's like a given. I use eBay, I use many other companies, and it's you get it for free. Do you think that the new business model is approaching, that my asset will be, will become valuable for you?
You already are.
Yeah. Well, I'll put it this way.
And you will to pay for it.
Well, let me go on.
The model exists today. It's just not a cash exchange, right? And so you see this in the form of, say, loyalty programs that a retailer may have, that in exchange for a certain promotional discount, you share some identifier that you're the same customer who was in that store a week ago also buying goods. And so that data exchange for value, that model exists today, and I think that those will become a little more sophisticated, but I don't really see in very many cases it turning into a cash exchange.
Yeah, I also think that there are cases where people don't realize that they're being paid in a free service, and I think that's when you use Google, you go, oh, whoa, there's no they're taking my data. We'll go, well, no, they're giving you a free service, and you're paying for it with your data. So I think you really have to think about it as exchange of value. There will be niche markets, though. I think probably. I think we're already seeing this around people. Drug companies paying for patients who will participate in trials. And so if I've seen a lot of startups whose business model is where we're going to find the right patients, for a trial and get paid that way. There are definitely some business models, but in general, you as a consumer saying, "Oh yeah, it's my data. You should pay me for it." Forget it. It's too valuable in the aggregate to you to be part of the pool. And if you opt out, you'll be a lot like I think it was some French websites back in the 90s who said, we don't want to be in search engines. And everybody said, okay, fine. And they very quickly changed their minds. All right. I think we're done. Thank you very, very much for this. I hope it was useful.